Generating a combined liftoff thrust of 1.5 million pounds, the RD-180 engine and 2 solid rocket boosters ignite to start ULA's Atlas V rocket on its trip to orbit. Shortly after liftoff, Atlas begins a pitchover to attain the proper flight path while minimizing the dynamic pressure the rocket experiences during flight. Then, Atlas V reaches Mach 1, the speed of sound. Within the next 2 minutes of first stage flight, the Atlas V rocket will more than triple its velocity following jettison of the 2 GEM 63 solid rocket boosters. Fighting against the force of gravity, the nearly 1 million pound rocket depletes the majority of its propellant. The main engine then shuts down, followed by release of the booster stage. The rocket now weighs a little more than 7% of what it did at liftoff. To deliver SBIRS GEO 6 to orbit, Centaur will perform 3 engine burns. Fueled by liquid hydrogen and liquid oxygen, the first burn takes the spacecraft orbital, reaching a LEO parking orbit. Then, once the rocket has climbed above the densest part of Earth's atmosphere, the payload fairing is jettisoned. After the first main engine cutoff, Centaur coasts around to the destination argument, or celestial longitude. The second burn then kicks the trajectory onto a geosynchronous transfer orbit with a maximum altitude in the geo belt. Following a multi-hour coast, Centaur comes alive for a final burn as it prepares to release the SBIRS spacecraft into a highly customized, enhanced, high-energy GTO orbit. Nearing end of mission, Centaur executes a guidance-commanded shutdown to complete the final burn, a capability which ensures precise orbit injection. More than 3 hours after liftoff, Centaur releases the 6th SBIRS GEO satellite for the United States Space Force, providing early missile warning detection.